So in terms of eye level, it's pretty self-explanatory. I'm getting some feedback. So it essentially means the height of your eyes above the ground. So if we've got our stick figure, if you're 6 feet tall, your eye level is probably going to be about 5.5 feet. We'll just do a quick guy here. So essentially we've got our ground plane on the bottom. I'm going to cheat with straight edges for the sake of brevity. And we've got our eye level parallel to the ground plane for 1 and 2 point perspective. And I'll get to that later. So after we've got eye level, we want to talk about the picture plane. Essentially, the picture plane is just your piece of paper. It could be any surface, whether that's a board, your drawing board. Think about it as an imaginary surface that we're holding up perpendicular to our faces. This is going to dictate where you want to put your imaginary eye level on your drawing, and it will correspond to the other elements that we're going into. So when we say we've got a cone of vision, essentially, the sphere that is your eyeball, it attracts light particles at a 60-degree angle. So if we were to draw this looking down, we've got our figure, and we've got our center line of vision, which is also the, I think, central visual ray according to the textbook. So we draw, maybe give them some shoulders so we know what we're looking at. We won't be doing this for this class, but it's important to know that you can take a 30, 60, 90 triangle to create your cone of vision. And all we want to do from that center line is expand out at 60 degrees. So this is, of course, a top view of our character. And to draw in our picture plane, we can put it in perpendicular to the center line of vision. So this would be our picture plane. If we were going to look at it in a more dimensional view, let's just do a real quick. We'll do a real quick figure kind of in perspective. Nothing fancy. So we want to do center line of vision out. And we want to say 60-degree cone of vision. And essentially why this matters is within the cone of vision, objects appear consistent, and outside of the cone of vision, objects will appear distorted. You can check where your cone of vision is by extending your arms straight out in front of you, rotate them outward until you can no longer see them, and that's going to be where the boundary of distortion lies. Now, we're not going to be drawing this out for our work in this course, but it's important to know about. So when we're working with our picture, we always want to know where our eye level is to get the right perspective for objects. Today it will be cubes. So what I will show you, we'll start with 1 point. Anything that is in line with our eye level is going to be flat. So if this is our eye level here, we want to put our center line of vision for 1 point perspective. Your vanishing point will be at the crosshairs here of the eye level and your center line. So those are the most important things that we want to talk about, and the cone will come into play later when you see that things are distorted. So because this center point here is your 1 point vanishing point, all of your oblique lines will extend back to it. In 1 point perspective, all verticals are square, straight up and down. So this is the same for 2 point. And the difference is in 1 point, when we see the exact front of an object, top and bottom will be completely horizontal. So 1 point perspective, right? Now we want to take all these corners right back to your vanishing point. And since the top of this cube is below our eye level, we will see the top. The other trick with 1 point is any line that I connect from one edge to another will automatically dictate the following edges. So let's just do an example here. I'll draw this bottom edge that we wouldn't actually see, but because we're drawing volumetrically, we're going to draw through and make these wireframe objects. So because I transferred a horizontal over left and right, I can also take that vertical. Where this line meets my oblique going back to the vanishing point, I can now draw a horizontal line. And because we're so close to the eye level, the top will be rather shallow. And now you can see I've got a very light horizontal on the top. I got my horizontal on the bottom, and I just connect the dots. So this is pretty simple. Now here's the other thing. So all of the objects in our 1 point will go back to that same vanishing point. So if we have our eye level, we know where a vanishing point is. And because we know this is our selected VP, this is our center line of vision. And you'll see as objects get closer to that center line of vision, the sides shallow out. This is an example of what not to do. You don't want to have multiple 1 point vanishing points within the same scene. You can have multiple 2 point, but if you're doing 1 point, it has to be the same vanishing point. So for your homework, you will be doing 6 cubes in 1 point and 6 cubes in 2 point. That means you can do overlapping, you can do more of a scene, you can take your own cubes and kind of select. So this would be like a layout for, it could be buildings, you could create a room, and if you have a cube, let's say you're looking at this cube head on, and you don't know how to find the vanishing point. The first thing you want to do is look for outside clues, other objects around your scene. But if you want to create an arbitrary perspective, what you can do is, let's say we pick 2 arbitrary lines that converge. So I'll say here and here. Now from these 2, we absolutely know where this vanishing point is going to be. Now I can connect this back to my other corners. And because this is our established vanishing point, I know that the eye level is horizontal and the center line of vision is perpendicular. CV, eye level. And as we know, the horizon line is the same as eye level for 1 and 2 point perspective. So I can say horizon. And like we did before, if we want to say create a room with this 1 point perspective, I'll say set the depth of the floor. I can throw it back horizontal and just take this line all the way around the cube the best I can. And then obviously we can add a little line weight to create atmospheric perspective, give it a little depth. So if we were to kind of fill in this space just rather quickly, you know, I can set a couple lines to mark where things are. Let's say we want to put, you know, like a couch, just simple blocks. And all of these front facing planes will be completely square. All of your obliques will travel back to that vanishing point. So when you're doing your homework, you could do an interesting series of kind of cubes out in space. Let's say you want to have different overlapping objects. And as long as you've got your center line and your eye level, you'll be able to figure out where that vanishing point is. Now, 2-point is a little different. 2-point can be challenging, but if you have a reference, you can steal those angles right off of your object. Before we get to that, okay, let's go with another piece of paper. Let's talk about 2-point. So, 2-point perspective is heavily dependent on the station point. Now what that means is where you're standing in relation to your picture. So just like in 1-point, we have our center line of vision, our eye level horizon. We take that down. To find your station point, all I did was take my 30, 60, 90 triangle and I just line up 30 degree on the left, 30 degree on the right. That's going to give you the dimensions for your cone of vision. Hang it for just a sec. So we're going to actually draw out the cone of vision in this top view. Handy dandy compass. So everything outside of this circle is going to be distorted. And that station point is pretty much just going to give you the kind of angle that you'd like to have on whatever it is you're drawing. Okay. So I want to go through real quick. I want to go eye level. Let's do center line. Because the 2-point vanishing points can be so spread out, I'm going to make this fairly small just so we can make it manageable on this size of paper. So what I want to do is I'll arbitrarily pick a width. I extend 30 degrees down from my eye level. This is, of course, my center. And then, because I have my station point, I automatically know that this reversed angle will go up to the left side of that horizon. So just because we can, we'll throw in our cone of vision. And what I'm going to talk about is not going to make sense immediately, but it will help you understand how these angles work out. So what I'm going to do is create one edge of a cube in 2-point perspective. What I want to do is arbitrarily select my left vanishing point depending on what angle I want. What I'm going to do is I will place it just outside the cone of vision. So this is arbitrary. Because we decide one, the other one will be fixed. So what I'll do is I'll extend my obliques back to the left vanishing point. Here's the tricky part. The 2 vanishing points are at a 90-degree angle to your station point. That's this guy down here, where we're standing, SP. Here's our VP. So what I want to do is take my triangle, extend this line down. Take out other guy here, to find this right vanishing point, it's going to be in a fixed position. Now here's what I'm talking about. They are kind of far apart. So now that I found this right VP, I can use this to create the right obliques. So now we've got two sides of a cube. Let's figure out where they end. So I can arbitrarily pick this right one, extend the corners back to the left vanishing point, and now I can pick my right edge. We'll just say right on the center line here. And this can extend back to my right vanishing point. Where the two sets of obliques meet, you'll see on the base and on the top of this, just drawing that vertical, because 1 point and 2 point, all verticals are straight up and down. The difference between 2 point and 1 point is all of parallel lines in 2 point converge. Front faces in 1 point remain square. So we can use these same two vanishing points to create any kind of object somewhere else on the page. Now that would mean that these lines are all square to our original object. What is square? So parallel. And then if we were going to create objects on the same surface but with different VPs, we can do that as well. If you give me just a second, I will lay some tracing paper over. So because we have the same scene, we're working with the same eye level, center line of vision, station point, and cone of vision. But there can be different sets of 2 point vanishing points. So just so we can see a little better, I'll redraw the eye level horizon. We can redraw our center line of vision. We'll just clarify this is our station point. And then from here, I can take another triangle. And what I'm going to see here is, because these are at a 90-degree relationship, as this shifts, our lines are going to extend farther out. So as one becomes more dramatic, the other becomes more slight. And that means it'll be more flat. So what I'll do is I'll take it to as far as I can on my paper, just to show you that the more slight the angle is, the closer to 1 point it will kind of revolve. And once it hits a certain point of no return, that's just 1 point. So we'll go way out here. So here's my second set, VP left, 90 degrees from this. My best recommendation for doing this 1 and 2 point would be look at objects in real life, especially cubes on the tabletop, and notice the angles and the relations, and I will show you how to capture those angles measuring with your pencil. So this is definitely the long drawn out way, but what I want to emphasize is as cubes turn, one side will be sharper, one side will be much more diminished. And then we want to draw through, because we always draw through. And then just connect the corners. So a 2 point can be multiple sets, and 1 point is always the same VP. You could have a 1-point object as well as 2-point objects in the same scene. Okay, so we got that. Just as an illustration, they always have this 90-degree relationship as they turn. Okie dokie. Let's look at. So you can have a 2-point with a very skinny side, and you'll still see a slight diminishment on this top, where as it starts to rotate, this becomes now a 1-point cube. Are there any questions on 1 and 2 point? All right, I'm going to end the recording.